Imagine being able to peer into the intricate details of a single cell, or unravel the mysteries of a virus's structure with unprecedented clarity. This is the power of electron microscopes, instruments that harness the incredible properties of electrons to reveal the hidden secrets of the universe at the smallest scales. But what sets these devices apart from traditional light microscopes is their ability to achieve resolutions that were once thought impossible, allowing us to study the building blocks of life and matter with a level of detail that was previously unimaginable. But how do these remarkable devices actually work? What lies beneath the sleek exteriors and complex controls? Prepare to be amazed as we delve into the intricate inner workings of electron microscopes, uncovering the ingenious engineering and scientific principles that make them possible. From the intricate dance of electrons to the sophisticated image processing techniques, we'll unravel the mysteries that have enabled these instruments to push the boundaries of scientific exploration. Welcome to AI Tech Underground. We're always exploring cutting-edge technology, like subscribe and hit that bell notification so you do not miss a single exciting tech video. At the heart of every electron microscope lies a remarkable feat of technology, the ability to generate and manipulate a beam of electrons. Unlike traditional light microscopes, which rely on visible light to illuminate specimens, electron microscopes utilize a stream of high-energy electrons to create incredibly detailed images. But what makes these electrons so special? It's their incredibly small wavelength, which allows them to interact with matter in ways that visible light simply cannot, revealing details that would otherwise remain hidden from view. The journey of these electrons begins in a specialized component called the electron gun. Here, a heated filament or a field emission source emits a steady stream of electrons, which are then accelerated through a series of electromagnetic lenses and apertures. These lenses, much like the glass lenses in an optical microscope, are designed to focus and control the path of the electron beam, ensuring that it strikes the specimen with pinpoint precision. But the engineering behind these lenses is truly remarkable, utilizing intricate electromagnetic fields to manipulate the trajectory of the electrons with incredible accuracy. But what happens when this beam of electrons interacts with the sample? That's where the true magic of electron microscopy takes place. As the electrons collide with the atoms and molecules within the specimen, they undergo a variety of interactions, including scattering and absorption. These interactions are carefully detected and analyzed by sophisticated sensors and detectors, allowing the microscope to reconstruct a highly detailed image of the sample's structure. But the process of interpreting these interactions is far from simple, requiring advanced computational techniques and algorithms to translate the raw data into meaningful visual representations. One of the key advantages of electron microscopes is their incredible resolving power, the ability to distinguish between incredibly small features. While traditional light microscopes are limited by the wavelength of visible light, electron microscopes can achieve resolutions down to the atomic scale, revealing details that would be impossible to see with any other imaging technique. This incredible resolving power has opened up new frontiers in fields such as materials, science, nanotechnology, and structural biology, allowing researchers to study the fundamental building blocks of matter with unprecedented clarity. As we delve deeper into the world of electron microscopy, we'll explore the different types of instruments available, each designed to tackle specific scientific challenges. From the workhorse transmission electron microscope, TM, which allows researchers to study the internal structure of materials with incredible detail, to the scanning electron microscope, SEM, which provides stunning three-dimensional images of a specimen's surface. We'll also explore the latest advancements in cryo-electron microscopy, a technique that has revolutionized the study of biological molecules by allowing researchers to image them in their native, hydrated state. Midway through our exploration, we'd like to take a moment to remind you that if you're enjoying this journey into the world of electron microscopy, be sure to subscribe to AI Tech Underground. Our channel is dedicated to bringing you the latest insights and discoveries from the cutting edge of science and technology. And by subscribing, you'll never miss an update. Join our community of curious minds as we explore the frontiers of human knowledge and unravel the mysteries of the universe. But the applications of electron microscopy extend far beyond the realms of scientific research. These powerful instruments have played a crucial role in fields as diverse as materials science, nanotechnology, and even forensics. We'll explore how electron microscopes have enabled groundbreaking discoveries and advancements, from the development of new materials with incredible strength and durability to the analysis of microscopic evidence in criminal investigations. You'll be amazed at the incredible impact these instruments have had on our daily lives, often in ways we rarely stop to consider. Throughout our journey, we'll ensure that every piece of information is accurate and factual, drawing from the latest research and insights from leading experts in the field. We'll delve into the intricate details of electron optics, specimen preparation techniques, and image analysis methods, ensuring that you gain a comprehensive understanding of this remarkable technology. But we'll also strive to make these complex concepts accessible and engaging, using vivid analogies and real-world examples to bring the science to life. But we won't just focus on the technical aspects. We'll also explore the human stories behind these incredible instruments. From the pioneering scientists who laid the foundations for electron microscopy to the modern-day researchers pushing the boundaries of what's possible, we'll uncover the passion, dedication, and ingenuity that drives scientific exploration. You'll be inspired by the incredible minds that have dedicated their lives to unlocking the secrets of the microscopic world, and the incredible breakthroughs that have resulted from their tireless efforts. As we approach the conclusion of our journey, we'll take a glimpse into the future of electron microscopy. With advancements in areas such as aberration correction, cryo-electron microscopy, and in situ imaging, the possibilities for scientific discovery are truly limitless. Imagine being able to watch biological processes unfold in real time, or study the behavior of materials under extreme conditions with unprecedented clarity. The future of electron microscopy promises to revolutionize our understanding of the world around us, opening up new frontiers of knowledge that were once thought impossible to explore. So, what are you waiting for? Like this video, subscribe to AI Tech Underground, and join us on this exhilarating exploration of electron microscopy. Together, we'll unlock the secrets of the microscopic world and gain a deeper appreciation for the incredible technology that has revolutionized our understanding of the universe at its smallest scales. Get ready to be amazed, inspired, and enlightened as we journey through the fascinating world of electron microscopy. Buckle up and prepare for an adventure that will change the way you look at the world around you, revealing the hidden beauty and complexity that lies within the smallest of structures.